All right, so let's continue from where we left off yesterday, and that is we're looking at error handling. We continue with error handling. Um, Again, this is we need this because we are doing rustlings, and the error handling chapter of the of rustlings requires that we also learn about the last thing we need to learn about is boxing errors, and that is in the Rust language reference, not the Rust book, but the Rust language reference. This is boxing arrows like here, but we're starting from we actually started from we just wanted to go over the whole section, right, or the whole chapter here. So it's like multiple error types. We started with this and wait, yeah, and yeah, and we left off here yesterday, I think. Yeah. So yeah, this is about we left off here. So it was about pulling results out of options, and we can do this with transpose. Yeah, so transpose can, so if we have a result that contains um in the OK variant, it contains an option, and for the error it has an error, right? So we can use transpose to make that an optional result, yeah, so and vice versa, right? So the other way around. So we can do that here with transpose. So that's what we learned yesterday, and yeah, let's continue. Now I think we will continue with this part. Yes. So define an error type. Yep. Okay. This is where we were supposed to continue with. So sometimes it simplifies the code to mask all of the different errors with a single type of error. Yeah, I think we also learned about this previously. Just like IO, the IO error that yeah can be returned. Yeah. Um, we'll show this in a custom with a custom error. Rust allows us to define our own error types. In general, a good error type represents different errors with the same type. Mhm. Okay. Presents nice error messages to the user. It's easy to compare with other types. Again, this is the Rust language reference that we're looking at. So you have like good, good error, right? So you have error, which and you have like you can pass an empty vec to it. Okay. Why is this good? It's easy to compare with other types. Presents neither messages to the users. I don't know about that one for here. Represents different errors with the same type. So this is like error T. So the bad one is that you have an error that takes a string, and then you say, please use a vector with at least one element to hold, okay? Okay, so and then another property of a good error type is that it can hold information about the error. So basically you have like an error that has that maybe takes a struct. No, no, this is not a struct. This is this yeah, this can actually be I mean maybe a tuple here, right? Or not a tuple. Um or what type is this? So that this doesn't I mean I would say this is a struct actually, like you can well, let's do this. I need to confirm this. I think I had like something here. We can check it quickly. Um, so we can have what was that? That was like bar char that has like what is that? C and position. Um, whatever. You wanted to do this, and then you had, let's say, uh, you had error that is a what is error here? I mean, this is just an example. I don't want to, but if you had like error, you define this. Would it be? What this would even be an enum actually, right? And then how would you? Yeah, if you wanted to then use this, you would say something like, I'm just trying to keep that. I want to use a different main, so it will be error. Can I do it like so? Bar chart. Can I say mm, it's not using my type here. My enum type. Yeah, because this is not a I don't have a module here, right? So I can, unless I would say model, uh, my mod. Um, wait, what? What is the in here? Expected one of. Um, wait, what's the syntax here? Am I missing? I'm missing something here. Oh, wait, no, wait. Um, so I define an enum, call it air, and then what? And it says it's wait, why? Enum variants can be. I don't know, like, what am I missing here? Enum variety. Why is this? Wait, if I call this, why is this a problem here? What? Uh, okay. That is the problem. It's actually a variant. It's for not it's an enum. So the variant it would be okay. Yeah, the variant. Um, I think that was the complaint. Yeah, missed the syntax. So if I had that, I don't find parsing in the scope. Yeah, that is okay. Passing error. I think I what did I do here with this one? Um, where does passing error come from again? I mean, I don't need this. I'm just gonna remove it. Wait, hold on. That's fine. So if I had this now, exactly. So this is a tuple. Sorry, expected function tuple or that, and what is it getting? Error. I think with this I have to say use, I guess, right? So use my mode. Yeah, right. Can I bring this into scope? I think I should say pub, yeah. Or I mean, I don't even need to make this pub to be able to use it, but I was gonna say use my mode, bring it in scope, and then say my mode. Yeah. So I know what I'm using here. Was defined multiple times. So this can go, I guess. So yeah, okay. So first issue, expected function tuple or struct found in num. Yeah, okay. So this would be char. Um, so it occurred in enum, yeah, and then putting in the type. Okay, yeah. So that would be lane. Um, actually do okay. Yeah, that's it. So what I was trying to get here was that this would be I don't know like yeah, so arrow. I was trying to write this and see. Yeah, okay. So we define an error type that is maybe an enum, right? Our own enum, and we can use it right with whatever else is there. This can equally be bad char. But wait, yeah, if this is bad char, we this is not how to do it. Yeah, bad char would be like so. Um, right? Yeah, exactly. This is what you'd have with this like so. So what this means is that This is an enum as well. So yeah, so plain is an enum. I mean, in this case, it means that error is an enum, bad char is an enum because of the way it's used here. So basically, you would have like, I just want some curious. Um, so you would have, wait, hold on. Okay, I just do this quickly. You define a normal struct. Well, enum case, it looks like so. Mm, so the bad char here, yeah, it's an enum variant. That's what I expect. Yes, it's an enum variant. But yep. So yeah, that's the thing. I expect a bad char would be uh an enum struct. I mean, that's what I wanted to. Okay, okay, that's fine. So we got it. It's okay. I'm just trying it out, right? I'm playing around with this, so yeah. Okay, continue. So this is the bad one. Bad one is like you have they're just showing. I mean, I think they're showing how to use this. So this can hold the information. The good one can hold the information um about the error, and they say this is good. Yeah, because you, I mean, the error then contains the information. In because it has like bad chart, so it has the it knows what caused the issue here. But the bad error here is like what you just have the string literal here. Okay, so and then another one is that it composes well with other errors. So this is you have an alias. So you're defining result t here, and then you say it's um, a type of result that is a type of result that a generic over is a generic result over the generic result over the result over the generic t, yeah, and double error, yeah, and then you define our own error types, maybe customized for our error handling cases. Now we'll be able to write our own errors, defer to an underlying error or something in between. So yeah, this is the um, double error struct we have here that implements debug and clone. Generation of an error is completely separate from how it's displayed. There's no need to be concerned about cluttering complex logic with display style. Note that we don't store any information about the errors. This means that we can't state which string failed to parse without modifying our types to carry this information. So with double error, we implement display here, and we say like we write and say invalid first item to double. Um, notice that we don't store any information about the errors. Just the string failed to parse. Okay. Yeah. So double first. So double first. So basically, you have a vector of string literals or reference to string literals, and you want to take the first element of the vector, and you want to change the error to our new type. So you do okay. I mean, the first will give you we give you, I think first here will give you uh a result. Yeah, because it's like you can use okay or here. Yeah, so you do okay and then or you want to get a double error. You want to create a double error. So you want to change the error to our type. Yeah, that's what you're doing here. Change the error to our type, double error, and then you do and then so you take the result of that. Um, yeah, you take the result of that, and then you process it. You call it another function here, which is you parse that. You can try to convert that to an I32. Oh no, sorry, hold on. So okay or error is like if it fails, you change the error to double error. Otherwise, you would do the and then, right? So if this is the okay here now. So you would take what was the first item there, and then you parse it to I32. If it succeeds, you want to update to the new error type here also. Yeah, so if parse, you're gonna try to parse this, and you're gonna do map error. So you map to the double error if it fails to parse. Otherwise, um you would multiply that by two after you succeed in doing that. Okay, so I would assume this. Okay, so generation of an error is completely separate from how it's displayed. There's no need to be concerned about cluttering complex logic with display style. Yeah, so basically you take care of the display here, or you worry about the generation here. Okay, and then you want to now print. You have a function that takes a result that is a result of I32, and by the way, that's our type here. So result or double error, right? So result, and then you do a match on you match on result. If it's okay, you print this. Otherwise, you that do that. So what you do numbers, um, empty and strings, and you try to do this. Okay, so this is define an error type. Um, okay, so what do we get from here is that we can do the processing and uh okay, so we have our error type, and then we have a way to generate it. So let's write this code here. I think we wrote a similar code before, but I think we didn't. Okay, the error. Um, Okay. So let's write that code. I think, wait, why do we do that? Yes. Was it here? No, wasn't. I think I probably got rid of it. Okay. I think it was, yeah, this was it. Yeah. I mean, in a way, right? So this is like the, yeah, I'm gonna bring this back. This is, mm, yeah, yeah, exactly. I think we had the functions there, right? Previously, like, yeah, we had it. So, mm, I think we should write it. Let's write it again. Yeah, I'm just writing the function again. So we have, let's have the code there. I'm just gonna write the function now. So it's a double first, yeah, double first function. That takes a vector of string, represents the string slices, and would return a result that was created by. So we had a type, we had an alias, um, result that was uh, result, the result enum. Yeah, result. I think result and double error it was, and we need to define the double error. Mhm. And then this will return as a result I32. Yeah. And what would happen here is, we would then do, we double first, so we'll try to get the first item of the vector by calling first, which returns us. Uh, yeah, okay, so this returns as an option, really. It's not a result. Yeah, that's the thing. I was saying result before it. Yeah, I mean, that makes sense for it to be an option, actually. First, and we're doing OKR. So OKR gives us what? Yeah, so okay, that's the thing. I think that was what was not clear before. It was confusing me. So OKR transforms an option into a result, mapping some V to OKV and none. Yeah, 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 that makes sense. Okay. So yeah, because I was like, no, I mean, first set item should be an option, not really a result, but I'm not sure why I was saying. Okay. So first, and then we do dot OKR. I mean, it's so cool that we have can I even call, no, it's not a result of it. I mean, you can, on an option, you can actually use transpose. Why don't we have transpose? Okay, yeah, because no, wait, think with, if I see this, do you not use the option? Do you not have, you have transpose an option? Yeah, exactly. So first, gives me an option. Why can't I call transpose on it? Oh wait, hold on. Um, will this be only if it return if it, I mean, the transpose function, but I don't see that there is any special implementation. Like I don't see that there's a trait that needs to be adhered to. Is it because it's an option of um is an option that's a reference? So what if I do to owned? I still don't have transpose. Wait, so owned would give me what now? No, it's not that actually. What I want is right. Okay, now I'm gonna have to go on a side quest. uh, Option has transpose function on it, yeah, to convert to a result that has option. Um, Whatever. Um, Given vec that is a vector of like vec dot first returns option, yeah. How can I call transpose on it? The first returns an option that is a reference to the to the generic type, yes. Here the type is first strings types, yeah. Okay. What a transpose is for. Uh-huh. So transpose would take the it only exists when your option contains. Okay, so it only exists when your option contains a result. Okay, that's why, which makes sense actually. So it's not just to convert that. So okay, only when you're okay, yeah, that makes sense. So when you have like option, like so contains a result, then you can call transpose. Okay, how to make it work if you um because vec first gives you options, you get another option of result. So it's only when it contains a result that we can do that. Okay. How to make it work if you actually want transpose. You want to convert something like option. So you need to have a result inside the option. Okay, makes sense. Get it. It's clear. So that would be like, yeah, like we just saw. Okay, so then we can do the transpose. Okay, if we wanted to. So map it to a result, and then we can do transpose on it if we wanted. Okay, I mean that would that's not what I want to do. So I'm just gonna side quest to see how that works. But yeah, so we get the first item, and then we do OKR like we wanted to before. So OKR would transform option into a result, which is yeah what we need in this case. Mapping that. Um, yeah, and then yeah. So what will be the or part? We have double error. Yeah, we have double error in this case, and then we say double. This is going to be. This is a. Wait. This is a result already. Yeah. So we can do that. It goes and then we can do and then. So we can take what is um value. We can take the OK value of the OK variant, yeah, and then do something with it, and then um here we can now try to work on it. So we can say s dot parse. This is string slice here. Parse. Yeah, and try to use the turbofetch operator here, and then say it goes the way. Yeah, we try to parse this, and if this succeeds, I mean, we can first handle the error like what we've seen, right? So map error. I mean, we haven't seen the map error yet, but I would imagine that this maps a result to okay to a different type. So it transforms. So it's only the error that gets transformed in this case, right? So the OK value, of course, we don't have that. So by applying a function to a contained error, so map error, um, and then this we can also say double error here. Yeah, and otherwise we can do a map. I guess we can still, yeah, we now have the integer value. You can actually just say exo. Yeah, this would, and we just return. Hmm, what is the problem? So it's a result. So, and then we do this, we map error. So this is result. Okay. And pass it error, and then we convert the result. We convert the error here to a double error expected expected value found struck double error. Okay, we also have that here actually. We have double error defined here. What does it say? Um, okay, so first of all, we have a problem from the beginning. So we have like type ls takes one generic, oh come on, but two what? Two found. And okay. I think we didn't define this is not defined properly, right? So we have a type, a result type. I have a type result that is result. So this I don't know. I mean, how you define the generic, how you define the list here is like, I think we did that before. Yes, you can do arguments where supplied. Wait, so I guess we're using the wrong type here then, right? So result, we should be, it should be, by default, it should be the result type, this one, yeah. So yeah, the result type. So it should be like T and double arrow, of course, why not? Okay. So help remove the unnecessary generic tag. I think we're missing something, but I can't easily just spot what we're missing. I have to fully qualify this. Is that it? Why is this not automatically estimated result? Wow. Okay. I mean, I was expecting that this would automatically be able to read all it, but yeah, that was it. So double error here. Expected value found. Wait, can I define? Yeah. Okay, I can define that without saying the. Okay. Yeah, it says, yeah, we need to. Yeah. Um, Ranunculus Acularis. Hello. Yeah, you made it. Yeah. Um, yeah. So we. I mean, I was just going over the Rust language reference. So basically, Rust links. I wanted to. We want to solve the Rust links exercises on error handling. Yeah, and there are a couple of sections that they recommend to read. One of them is like error handling from the Rust book. We already took care of this. There's also generics, which we have done. There is the result type, which we've also taken care of. This result is from, so basically this one is from the Rust book. No, actually, I think they are all from, yeah, this is from the Rust book. Yes, it's from the Rust book. But these ones, I mean, result and boxing errors are from the Rust language reference, which we're doing now, right? So I was just, so this is the Rust language reference that we're using here, where they, yeah, this is the chapter where they talk about error handling. So we've gone through, I think, yeah, we've read them, and then we're now here. So this is what want to wrap up. Yeah. So talking about like defining an error type. So I'm following, I'm continuing from where I left off yesterday, and there we sort of defined a double first function that would take a vector and try to process the vector. It tries to take it takes the first element of the vector and tries to convert it to an integer type I32, and then double the value. So that's it. But doing this with error handling, right? And doing this with the option and result, and like using that. So that's what I was trying to do. I was trying to just implement something like what I see here. So what I've done is, I think this is not needed. So what I've done here is to have a, so I defined a result type. So this is like an alias. You can create an alias in Rust where um, an alias is just like a reference to your type. So like a short, so it helps us like to create a short form. So instead of us to always have to write results and then our type and then double error, we can just create this alias here and say this is our result that we created, this type, and it will always just say it will always have the specific type we passed to it, while the error would always be double error. So results usually would be a type and an error. So result has like results enum has OK variant and the error variant, right? So in this case, the OK variant will be the type we pass, and the error variant will always be double error. So that's what we've created here. We just also created a unit struct for double error, just for us to use this and see. And it's also telling us here that we probably should be implementing debug trait on this. And to do that, we would, wait, I think it's derive a, yeah, derive debug. Yeah. So that's taken care of. So what happens here is that this is our function here, double first that we wrote, that we were talking about. So it takes a vector of string literals, and now we start to process it. We do first. The first gets us the first element from the vector, which would return us an option, and the value in the option, or in the sum in the option, the type of the option is reference to string slice, and then we can uh, we can convert this option type to a result by doing OKR. So which we do here. So OKR would convert. So basically, yeah, OKR would, yeah, to transform the option T into result of the same type or error by mapping sum v to OKV. So basically, option has two variants. Options the option enum has two variants. It has the OK variant and the sorry. Option has the sum variant and the none. Yeah. So it will map the sum to result OK, and the none would map to error. So it'd be just a way to transform it basically. So that's what we're doing here. So this would be first we give us an option. OKR transforms the option to a result. Otherwise, the error, we want to convert the error automatically to our error type. That's why we say, okay, otherwise, convert to a double error. We also use this function here to act on the result. So now we have a result of string, um, refers to string literal and string slice, sorry, and double error. Now we can process it, we can continue with, and then we would get the um, the value in the OK variant of the result, and we can process it. So basically, the chain is like, get the first item here. If it's an option, I mean, sorry, get the first item here. It will return us an option. We convert that option to a result or error. This is good. This is what will happen for the error side. Otherwise, um, if we succeed in converting it to a result, then we continue to process here. So this would be the value in the OK variant of the result, and we would then process, we would then call this function, right? This is what the and then will do. And the function is to parse that string value. In this case, we use the turbo feature operator to convert this to an I32 type. So basically parsing this to this type. If it succeeds, then we want to, no, sorry, if it doesn't succeed, that's what map error does. So because this would return us a result or a pass error. Now we want to convert this passing error into our double error. So that's what we do with map error here. Yeah, otherwise if this succeeds, then it should get the value and just double it. That's all. It's, I guess it's supposed to be I wouldn't say it's functional style, but it's just like a flow or like a workflow, whatever. So yeah, it's so but we have a problem. What is it? What is it here? Expected what? Expected, what do you expect here? Expected if an F1 found double error. Expected passing error closure found double error. Um, so what did we do wrong here? We call and then we let me try to run this here. I think I'll see better. Not that one. Mm, so this is it here. So map error expected f once, a function once, a passing error, closure found, double error. Okay, so what? So we cannot pass a double error. Oh, I think think my internet was switching off just now. I hope it's still, I don't know if it's still connected. Oh no, it's gone. I don't know if I'm still live or it's like, I don't know. Uh, are we are we still live or maybe I need to reconnect or rejoin because I think there was some disruption. Uh, okay, I don't know if I need to reconnect or not, but yeah, I think this should still be working, right? I hope. I think. But anyway, I had to reconnect and yeah. So I was running this. Let's see what we have here as the issue. Um, so we have so expected and function one sparse int error closure found double error. So required by a bound introduced by this call. So what? I think that's a trade bound. So help the trait help the trait is not implemented. So passing error is not implemented for double error. I think I have an idea. Passing error with passing error is not implemented for double error. I think I saw, is it I don't know, like I think I saw they were implementing clone somewhere. I think I saw, I don't know how do you do that? Is it like so? No? Yeah, that's it actually. So, okay, so that was the problem, right? So we just needed to implement a clone trait for that to, wait, is that it? I guess, yeah. Just we need to implement the clone trait for that to happen. Okay. And what's the other complaint here? The other complaint is that failed to resolve. No, that's not the problem. That's not the thing actually, because it's still have that error. Nah, I don't know what this one is actually because, mm, but what are we doing wrong? So map map error. It maps the results uh, of type the generic type, the type and the error to result. Basically, it leaves the OK part and only transforms the error from E to F, from type E to F. That's what it would do here by applying a function to a contained error, leaving the OK untouched. Yes. So what? And these are examples. So you can do a map error. Um, what did you do? Stringify. So you have a function. Okay, you have a function called stringify. Okay. Okay, that's okay. So stringify is the function that takes um stringify is a function that takes a type, an x a U32 type, and um converts and returns a string. Yes, and then you are, so that is a function. Map error is a function. Yes, I think that's our problem. So yes, um, so map error is a function, not necessarily a so mm, can we do it like so? Yeah, we can do it like so. Yep. So yeah, I think that was the issue. So unused variable. I mean, that's fine. So what else is the thing there? And this complaint here is that it fails to resolve undeclared creator model error because of blah 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 blah. Um, yeah. So this one was something I was trying before. I was just I mean, main function normally should return you like unit type. So basically this is how you write your main function, right? So it doesn't really return you don't have a return type apart from it's just unit type. But I was practicing this. Seeing that this you can also main function can also return you a result type. So it can return your results of unit type and then box the error. Error is like the generic error that is defined in the IO crate. So we need to bring that into scope to use it. Yeah. So it's going to be I think it's STD error. Yeah. What type list takes one argument. Come on. Is it say STD error is IO error actually, right? No. STD is it? No, because actually we say error. We're doing this from error, right? Um, wait, hold on. Fail to resolve module error. Let's see. That's previously, yeah, so that's fine. That's fine. Yeah, so this is what I'm complaining about. Type layers takes one generic argument, but two arguments were supplied. Ah, yes, that's the problem. Ah, okay, so the problem is that result here, because we went ahead and uh, defined our own type, our own alias, right? So we created a new alias for ourselves here. Yep, and this is now shadowing this one, right? So normally the preload would load results for us. So this result here is not, we created our own type. So this is overshadowing stuff here. So what needs to happen is we need to specify the result that we want to return from here. I think now is, I don't know, where does that one come from? We would have to say use, I think it's std. So where does result come from? Is it error? Error, is it result? No. Uh, yeah, it's actually there. Actually, std the result. Yeah. We probably don't even have to bring it into scope like that. We can just do std result, result, yeah, and that will be fine. And then error, oh, come on, it's much easier to do it like so. Yeah, is std result, and then that should be fine. And here we can say, yeah, result, and then here for error, we, why does error now? Okay, yeah, it should also be, I think it's use std error as well. So these two of them need to be run into scope, and that will be fine. Yep. Okay, so I'm gonna wrap it here. Wrap it up here. Um, so first, so we've been able to write this function. This, yeah. I'm not sure why is this important. Like this one. Why do we don't need this here, right? I mean, but anyway. So we've been able to, so double first. We've written this using the using OK error, and then and then doing the processing for ourselves with map error and map. Yeah. We also have a main method that so we can also run this, yeah, and then see. So cargo run. Yeah. So um double first. So for the first one, um yeah, it's supposed to give us a result of type I32. The first item in this the first item for where you have numbers, right? Yeah, the first one, it take the first item 98, and then wait, no, hold on. Why does it say, yeah, exactly 98, and then it will double it, yeah. So 196, which is, and it gives us like the okay of that. That's correct because it's result. For the second one, it's an empty vector, so it will just give us an error, and it converted the error type, which was a parsing error actually, to our error type that we created, which is the double error. And the third one, the first item here is a string, so it would not be able to convert it. It will also be a parsing error, and it converted that to a double error. So basically, uh, which is this, like either it gives us the value or it gives us a double error. So okay, so I think that's a good place to leave it. Yeah, so that's defining error type. We will continue with boxing errors tomorrow. All right. Have a good evening and see you on the next one.